Now, let us continue with the array implementation of the stack of operations. The array implementation of a stack is created before it is used. This declaration may be performed either globally or local to the main function. If we declare the stack as a global array, then it can be used everywhere and in any function. If we declare the same array inside a main function, then we can be using inside that function only, and if we want to perform any one of the operations on the stack using any one of the sub functions, we have to pass it as a parameter. Then the symbolic constant is defined called size. Hash define size 50. Here 50 is the size that I am defining for my stack array, and after that I am globally creating a stack variable with the name stack itself, followed by the size enclosed in square brackets, and is of type integer. That means the stack can manage the integers, that is homogeneous data items, in the form of an array. Then top is the index variable that I am using to insert the data items or the delete the data items, and is initialized to -1. Then push is the first operation that we discuss. Push is the operation on a stack used to insert a new item into the stack. Here the data items are inserted into the stack using the push operation. To push an item, we have to make the top pointer or index to point to an empty location. Since top is initially set to -1, we have to increment the value of top first, and then only we can store the new data item at that particular location. Similarly, before pushing an item, we have to check whether the stack has an empty location at the top or not. That means push is only possible when the data items are possible to insert. That is, there is some empty location available at the top of the stack, then only we can insert the data items. Otherwise, we cannot insert the data items. Next, if there is some space at the top of the stack, then only it is possible to insert or push the element. Otherwise, the stack enters a state called overflow. So when the top pointer reaches the maximum size of the stack, that is top equal to size -1, we say that the stack is full, and this condition is called overflow condition. Here I present a simple algorithm for push operation. For this push operation, there are three things involved. One is the data structure. The data structure we are using is the stack as an array with size number of elements. Input is a parameter, n is a parameter, the integer data item to push, and output of this operation is the stack inserted with n at the top. And the steps in this algorithm are: we start, then immediately after starting the push algorithm, we verify whether top is reaching or has reached to the size -1 or not. If top value is equal to size -1, then we say stack overflow. So this check is for full, stack full. If the value of top is not equal to size -1, then the algorithm proceeds to the insert operation. Otherwise, it is terminated. Initially top is -1 equal to size -1, that is 49 is false, so it moves down to this. And here first we have to increment the value of top so that top points to an empty location. Increment top point to an empty location. Then set n in that topmost element location of stack. That's what is given here. Store or assign the value of n at top index of the stack. Next, we have the pop operation as usual. The delete operation on a stack is called the pop operation. In this operation, the topmost data item available can only be removed. That is, the stack follows the LIFO ordering. Whatever the item that is entered into the stack is the only item that can be removed first. If we want to remove the topmost item, we must ensure that the stack is having some elements in it. This leads to another condition on a stack called empty condition. That condition is also called underflow. before deleting an item, we must check whether the value of top is pointing to some valid index or not. If top is not pointing to -1, it means that there are some values present in it, then you can delete it. Otherwise, if top equal to -1, then stack is empty. When the value of top is equal to -1, we cannot delete any item. This situation is called empty stack. When an item is deleted, the value of index variable top is decremented by 1 so that it points to the next element to delete. Now the algorithm. Again, there are three different things available in this case. One is the stack, an array with size number of elements, top, the index variable. There is no input, there is no parameter to the pop operation, but there is a return value from the pop operation. So nil. Then the output of this function is the topmost element which is stored in n and is returned to the main function. The algorithm is proceeded like this. Start. First we verify whether top is equal to -1 or not. If top equal to -1, that means the stack is in underflow state, so we cannot continue. So empty stack is the message we generate. Otherwise, it continues to this. The topmost element identified by top is returned to n or assigned to n. That is what given here. Fetch the top item of the stack and then decrement value of top by 1. Top equal to top minus 1. So top equal to top minus 1, decrement top by 1 and return n. Then the last one is the show operation. Here, this operation is used to display the data items of the stack in LIFO order, that is last in first out order. The order in which the data items are inserted, in the same order the data items are displayed. So the item that has been inserted last is printed first. Before printing the values, we have to verify whether the stack has some values to print or not. That is verify underflow condition. Again, the algorithm is start. First verify whether top equal to -1 or not. If top equal to -1, there is no stack or there is no data items present in the stack. So it is in underflow status. So we display stack is empty and return. Otherwise, take another integer variable called I, which is assigned to the value of top. Then set the loop variable I to the value of top. Then repeat the steps. These are the two steps which we have to repeatedly perform until I value is greater than or equal to 0, while the I value of I is greater than or equal to 0. So write the value of stack of I, that is the ith element. The value present at ith element of the stack is displayed first, and then the value of I is decremented to 1, so that I will be decremented by 1 and it will be continued while the value of I is equal to 0 or greater than 0. When the value of I becomes less than 0, then it is stop. So this is your start show function.